problem set 18 is really the same stuff as problem set 17. You're going to simplify using the distributive law, and then you're going to, at the very end, it asks you to factor your final answer. At the end of this video, one of the things I'd like to do, if I have time, I'm going to give you a reason why a negative times a negative is positive. Okay, why a negative integer multiplied by a negative integer is a positive integer. Okay, we'll do that at the very end. And then in the next video, I'll show you another reason. Okay. Okay. First of all, let's again, since factoring is so important here, let's do some factoring problems here. Factor. What is the definition again? Well, what does it mean to factor something? What are you doing when you factor it? You're writing it as a product. You're writing it in product form. Isn't this already factored? Would you call this a product of things? No. This is the sum of things. This is the sum of two terms. So this is additive form. Do you have to use the distributive law here? Yeah, because they're two terms and they're not like terms. So the greatest common factor is a 6a, isn't it? So you get 6a times the quantity 3b plus 2. I wrote a negative 6a. I took the negative out also because since each of these are negative, I like to do that. It's a good idea. Here, speaking of taking the negative 1 out, I think that's about all you could do here, right? Since they each have a factor of negative 1, you could pull the negative 1 factor out and be negative 1 times x plus y. Now when you're doing these factoring problems, always look to combine like terms. Are there any like terms here? No? Okay, then what's the greatest common factor? Greatest common factor, I don't really see one other than 1. So your answer would be either can't be factored, that would be okay, just to say cannot be factored, or to put a 1 times the quantity. Make sure you put parentheses around it. That would be good too. So how would you factor this? Notice you can combine negative 10x plus x is negative 9x. And then what you could do is factor out, what would you factor out of there? I would factor a negative 3 out. Negative 3 times the quantity 3x plus y. There you go. Okay, so what we're going to do here, I'm just going to go right into it and give you some to practice, and then we'll go over them. So go ahead and hit the pause button and try these. Okay, on the first one, you want to simplify. Are there any like terms? It turns out the first term and the last term are like terms, because remember, yx is the same as xy. So when you add those together, you get negative 5xy plus 5x, and then the greatest common factor would be a 5x. 5x times the quantity negative y plus 1. On this one, let's see, what would you do first? Inside the innermost parentheses, can you combine those? No. So the first step would be to use the distributive law. Remember, that's a factor of negative 1, isn't it? That's a factor of negative 1 right there. So we'd multiply everything by negative 1. By the way, what is this? What is the opposite of negative 6w? What is that? Well, that's just 6w, isn't it? This is the opposite of a negative number, so it's just 6w. And then here you get negative 1 plus negative w. What would you do now? Combine the w's? They actually cancel, don't they? W plus negative w, they cancel, so you just have negative 1 inside. Negative 2 times negative 1 is 2, so you get 2 plus 6w, and it asks you to factor your final answer, so you'd write it as 2 times the quantity 3w plus 1. Hit the pause button and try these two. So on the first one, we're looking inside the innermost parentheses. Can you combine anything in there? No. So again, we're going to use the distributive law, multiply this factor of negative 1 by each of these. And again, when you see negative of negative 4, that's just 4, right? It's the additive inverse of negative 4, which is just 4. So this becomes a 4. This becomes negative 3 plus x. Make sure you write the whole problem down carefully. Next we would combine the x's. So you get, inside the parentheses, you get 2x plus negative 3. Make sure you write the whole problem down. Next step would be to distribute the 2 out here to each of them. And you get this. And then we're going to combine the negative 6 with the 4. And then the last step, remember, it does say to factor your final answer, so you would factor out a 2. That's your final answer, 2 times 2x. 2 times the quantity 2x plus negative 1. On this one, I don't see anything to combine inside the parentheses, so we're going to use the distributive law here. Now what's going on over here? Well, how would you handle this one? Well, I mean, there's no number in front of the parentheses. Actually, if you want, if you really insist, you can put a 1 there. But it doesn't really change anything. If you distribute the 1, isn't it the same thing as just dropping the parentheses? So that's what you can do. It's not important. Those parentheses are really not serving a purpose. You could just drop them. Or you could distribute a 1. It's the same answer. So when you multiply the first one out, multiply each term by -2, you get 8 alpha plus -2 beta. Here you just get 2 beta plus 6 alpha. If you combine the betas, I think they cancel, don't they? The betas cancel. So you just have 8 alpha plus 6 alpha, which is 14 alpha. You can factor that as 2 times 7 times alpha. Okay, let's do one more set, and then I'll show you why. I'll give you a reason why a negative number, a negative integer times a negative integer is a positive integer. That's coming up. Okay, try these two. Hit the pause button and try these two. Now on the first one, did you recognize that these are like terms inside of here, and so are these? So that would be a good first step. In fact, once you do that, you realize that you don't have to use the distributive law at all on this, on number 5. This is just -2a times 8b, which is just -16ab. And here this is 4 times 2ab, which is just 8ab. Final answer is -8ab, but it does say to factor, so I'd write it as -1 times 2 times 2 times 2 times a times b. Now, if you did use the distributive law, it wouldn't be wrong. You could still get to that same answer. It's just a little more work. It's good habit, a good advice is to always look to combine like terms. Okay, on this last one then, inside the innermost parentheses, you see y plus 1. Those aren't like terms. So the first step that you can do here is distribute this 2. We write the whole problem down though. It's still 3a times the quantity, -3y plus 2y plus 2 plus 3ay. Now let's combine like terms. See the -3y and the y, we get the -3y and the 2y, I should say, becomes -y right there. And then we're going to distribute the 3a to each of these inside the square brackets. We get this. And then the 3ay's cancel. Look at that. This cancels with this. The first term cancels with the last term, and you just have 6a, which can be written as 2 times 3 times a. There you go. Okay, so what I'm going to do now is, with the time that's left, I'm going to give you a reason why when you multiply two negative integers together, you get a positive integer. I know some of you probably won't like this reason. It's kind of twisted. In problem set 19, I'll show you, I think, a better way, an easier way to understand, but this is one way. And the reason why I didn't tell you till now is because it uses the distributive law, okay? We hadn't covered the distributive law when we talked about multiplying negative integers. That's why we had to wait. But here we go. Let's look at this problem. We're going to ask the question, why does -3 times -2 equal 6? If we can answer that, then you'll see why it works. Okay, here we go. Let's look at this problem here. Do you know what the answer is to this problem? -3 times the quantity 2 plus -2. I think you know what the answer is, because when you follow the order of operations, you get 0 inside. Anything times 0 is 0. So do you agree that this whole thing is going to equal 0? Yeah. Okay. Now what we're going to do is we're going to use the distributive law on this, which is legal. The -3 is going to multiply each of these. So you get -3 times 2. We're not going to multiply it out yet, though. We're just going to write it in this form. -3 times 2 plus -3 times -2. Okay? You following me here? And we know it equals 0 because we know this inside is 0. So the whole thing has to equal 0. Now see this first one, -3 times 2? We know that's -6 because the definition of multiplication, this can be thought of as -3 plus -3, which is -6. So we know that this term is -6. The question is, what does this term have to equal, right? That's where we're going with this. We're almost done. All right, so think of it this way. We have -6 plus this thing equals 0. You see? -6 plus this thing equals 0. This thing is what's inside the box. I just replaced it with a box so you can see it better. What is it? What number is it that you add to -6 to get 0? The answer is 6. So it has to be 6. It follows from the distributive law. So that's a reason why when you multiply -3 times -2, it must equal positive 6. I knew you would like that. Anyway, in problem set 19, next time we'll look at another reason why that's true. See you next time. Bye-bye.